Welcome to Data Engineering with Subhadip. Today, we are diving into an exciting topic, vector databases for data engineering. Get ready to unlock the power of intelligent data processing for your AI applications. So, what exactly are vector databases? They store data as high-dimensional vectors, also known as embeddings. They are specifically designed for efficient similarity search and are critical for AI applications like large language models and retrieval-augmented generation. These databases bridge the gap between unstructured data and semantic understanding, and importantly, they help overcome LLM limitations like hallucinations. Let us clarify what embeddings are. Embeddings are numerical representations of various data types, like text, images, or audio. They capture the semantic meaning and context of the data. These are typically generated by advanced AI models. The key idea is that similar items will have their vectors positioned closer to each other in this embedding space, forming the foundation for intelligent search and retrieval. So how does similarity search work? First, you take a query, like a piece of text, and convert it into an embedding. Then, this query embedding is compared with all the stored embeddings in your database. This comparison typically uses distance metrics, such as cosine similarity or Euclidean distance. The goal is to retrieve the data points that are most semantically similar to your query. This approach is far more powerful than traditional keyword search for gaining contextual understanding. Data engineers play a crucial role in building retrieval-augmented generation or RAG pipelines. RAG combines the power of large language models with external knowledge bases. As data engineers, our role is to build, manage, and optimize the data ingestion and retrieval components. This includes extracting data, generating embeddings, and storing them efficiently in a vector database while ensuring the freshness, reliability, and scalability of the vector store. Let's look at some popular vector databases. Pinecone is a managed, scalable vector database widely used for production RAG systems. Weaviate is an open-source, cloud-native vector search engine offering a GraphQL API. FAISS, or Facebook AI Similarity Search, is a library for efficient similarity search and clustering of dense vectors. And finally, pgvector is an open-source extension for Postgres, transforming your relational database into a powerful vector database. Now let us take a deep dive into pgvector with Postgres. pgvector is an open-source extension for Postgres that adds a vector, data type, and distance operators. This allows you to store and query embeddings directly within your existing Postgres database. It is an excellent choice for smaller-scale projects or when you prefer a single data store, as it integrates seamlessly with existing PostgreSQL setups. Let's walk through a practical example with pgvector. First, you will need to install the pgvector extension. Then, connect to your PostgreSQL database and create the extension using SQL. After that, you create a table like this, Documents, Table, which will store your text content and its corresponding embedding. Notice the vector data type with 1536 dimensions, suitable for OpenAI's ADA 002 embeddings. Here's the Python code for data ingestion. First, we import necessary libraries and initialize OpenAI with our API key. The get_embedding function uses OpenAI's API to generate embeddings for a given text. We then connect to our PostgreSQL database, define some sample documents, and iterate through them. For each document, we generate an embedding and insert both the content and the embedding into our paid Documents table. Finally, we commit the transaction and close the connections. Now for the similarity search. We define a query text and generate its embedding using the same get_embedding function. Then, we execute a SQL query using the less than equals greater than operator, also known as the less than equals greater than operator provided by pgvector, which calculates cosine distance. We order the results by distance and retrieve the top three. The output shows our query followed by the most similar documents and their calculated distances. A lower distance indicates higher similarity. Let's summarize our key takeaways. Vector databases are essential for AI-driven applications. Embeddings are crucial as they capture the semantic meaning of your data. Similarity search allows us to find contextually relevant information effectively. Data engineers are vital for building the robust backbone of RAG pipelines. And finally, tools like Pinecone, Weaviate, FAISS, and pgvector are empowering modern data stacks with intelligent capabilities. Thank you for watching. I hope you found this deep dive into vector databases insightful. If you enjoyed the content, please do not forget to like, share, and subscribe to Data Engineering with Subhadeep. Your support helps me create more valuable content.